I am super pumped to walk you through this blueprint for modernizing your tech stack using Google's Gemma 4. We're looking at a fundamental shift in how we build, test, and deploy code securely, and I'm going to show you exactly how to execute it right on your own machines.
So here's our roadmap for today. We are hitting 1. Enterprise privacy and the Apache license. 2. Dense versus mixture of experts. 3. Sizing models for local hardware. 4. Deploying your local coding assistant. 5. Advanced local coding workflows. And 6. Hybrid AI for bug fixes. We'll start with the high-level architecture and zoom all the way down to hands-on deployment. Let's just dive right in.
Section 1. Enterprise privacy and the Apache license. Let's tackle the massive elephant in the room for any serious dev team: enterprise security and who actually owns your data.
How do you actually run frontier AI without compromising your enterprise data? We've all seen the massive opportunity here to speed up development, right? But routing your sensitive, proprietary code to some cloud API? Yeah, that poses a major privacy risk. You're opening yourself up to man-in-the-middle attacks, third-party breaches, and compliance nightmares. If you work in healthcare, fintech, or government, sending code to a remote server is simply a non-starter.
And honestly, this brilliantly illustrates why Gemma 4 is an absolute game changer. Previous open-weight models often came with these really convoluted acceptable use policies. But Gemma 4, it operates on the fully open Apache 2.0 license. This gives us the freedom to build and commercially sell our products without our proprietary data ever leaving the building. You literally have the total freedom to fine-tune Gemma 4 models on your own private coding datasets. Absolutely no vendor lock-in, just pure local power.
Moving on to Section 2, Dense versus Mixture of Experts Architectures. Now let's look under the hood at the actual computer science choices making this local deployment possible.
We really need to define the difference between dense and sparse architectures. Think of a dense model, like the 31 billion parameter variant, as this giant brain where every single parameter fires for every single generated token. It's pure, brute force power, great for the toughest logic problems. But contrast that with the 26 billion parameter mixture of experts, or MOE model. Think of the MOE not as a giant network firing all at once, but as a highly efficient dispatcher. It has 128 distinct expert networks, but for any given word, it only calls on the 8 most relevant specialists.
Now, check out the incredible efficiency gains on this table. Look at the benchmark scores from the Arena AI community. The 26B MOAC achieves a score of 1441. That is basically neck and neck with the massive 31B dense model's 1452. But here is the kicker. Look at the active parameters at runtime. The MOE is only activating 3.8 billion parameters to achieve that score. You're getting frontier-level performance while operating at roughly 1/7 the compute cost. For most coding tasks on local machines, the MOE is absolutely your go-to architecture.
All right, Section 3, Sizing Models for Local Hardware. Let's talk about what this means for the machines sitting on your desk. Because, the most advanced architecture in the world doesn't matter if it just turns your laptop into a space heater and crashes your system. The crucial point is matching the right model to your hardware. The 4B effective parameter model is unbelievably fast for laptop developers. On an M4 Pro chip with 24 gigs of unified memory, you can easily hit 31 tokens a second. The 26B model, though, that requires a dedicated desktop setup. Think 128 gigs of RAM and a beefy GPU like an RTX 4060 Ti. And hey, quick tip, pay attention to quantizations. An 8-bit quantization retains higher reasoning quality but eats up more memory, around 12 gigs for the smaller models, while a 4-bit model saves memory but sacrifices a tiny bit of fidelity.
Which brings us to Section 4, Deploying your local coding assistant. Time for execution. Let's actually get this running locally.
Here is your step-by-step workflow for integrating this right into your coding environment, bypassing cloud dependencies completely. First up, just install LM Studio. It gives you a really clean UI so you aren't fighting with command lines. Download your Gemma 4 model right in the app. Next, you'll want to connect that local runner to your IDE like VS Code. You can use the awesome open-source Continue extension or even a dedicated agentic terminal like OpenCode.
Now, when setting up LM Studio and your tools, your configuration checklist is vital. Set file reading and editing to automatic so the model can seamlessly scan your codebase. But, and I can't stress this enough, always configure terminal commands to require your manual approval. Safety first. And finally, make sure you enable Think Mode. This forces the model to display its chain-of-thought reasoning before outputting code, which is an absolute lifesaver for complex logic tasks.
Let's level up. Section 5. Advanced Local Coding Workflows. Once you are securely set up, you can push the limits of these agents. Since Gemma 4 is fully multi-model,
You can literally drop image references, like a UI mockup or a quick snap of a whiteboard, straight into your chat. The model analyzes the image and generates the precise HTML and CSS to build that front-end layout. It's wild! Also, take advantage of chat branching. This feature lets you safely test risky code variations down a separate conversational path without cluttering up your main context.
Of course, I'd love to say it's magic, but it won't always be perfect. When you're tackling something complex, like C++ game dev, you are inevitably going to hit syntax errors. The manual troubleshooting workflow here is simple. Find the specific failing lines in your console, feed those exact errors right back to the local model, and let it attempt a line replacement. If it gets stuck, it'll autonomously rewrite the script to bypass the blockage.
Finally, Section 6, Hybrid AI for Bug Fixes. Let's look at an optimized strategy for real-world enterprise development.
Moving forward, routing different tasks to different models is the ultimate efficiency hack. We call this the hybrid workflow. You use your blazing fast, zero-cost local model to do all that heavy initial scaffolding and boilerplate generation. You manually troubleshoot the minor syntax errors locally. But if you hit a truly stubborn, complex bug, that's when you route just that specific, isolated problem up to a larger cloud model. You drastically cut your API costs while maintaining premium performance across the board.
So, I'm going to leave you with this final, provocative thought to chew on. We now have a permissive Apache 2.0 license, massive compute efficiency through mixture of experts, and total data privacy. If local open weights are bringing this much secure frontier-level power directly inside our own walls at zero runtime cost, what limits are actually left on your infrastructure? Think about how you are going to redesign your tech stack tomorrow. Thank you so much for joining me for this explainer. Now go build something incredible.